Hey guys, welcome back. Fred here, AF Math and Engineering. We're going to do a quick video for you on static determinacy, indeterminacy, and stability. So essentially what we're going to do is we're just going to do 4 problems. They're not too hard. This is an easy section, but I'm going to show you just a couple things to look out for. Once you do 4 of these, you should be good to go. So let's take a look at the 3 formulas that we have here, okay? And I've defined the variables in these formulas. So M is for members, R is for reactions, J is for joints, and EC, E sub C, which is equations of condition. In our case, we're going to consider as internal hinges, okay? So that's pretty much it, okay? And whenever one of these appear, you just add a single value to each variable, and you just see which category it fits into. So it can either be statically unstable, statically determinate, or statically indeterminate, okay? And, determinacy simply means, if you haven't done this yet, if this is the first time that you're doing it, determinacy essentially means that the number of equations that we have in order to evaluate the structure is not enough. So we have more reactions than we have equations, and so we have more unknowns than equations. So that's essentially what indeterminacy means. Okay, if we have less unknowns than we have equations, then what we have what's called a statically unstable frame. Okay, so a frame which has infinite solutions. So let's, with that being said, let's take a look at the first question. Okay, so the one thing that you need to take away from this is what constitutes a member, what constitutes a joint, and what constitutes an internal hinge. Okay, so when we say internal hinge, we represent it like this. It could be an internal shear connection on a steel girder attached to a column where only the web is bolted with an angle. That could be the case, but in this case, it's represented here as just a circle. Okay, so that's a hinge there. So what constitutes a member? Let's start with the first one. So this would be a member here, okay, and then we have a joint, and then we have another member. Okay, so it's a continuous portion of the frame. All right, and so this would be a member here, but this joint separates these two, so this is 2 members. So we have 1, 2, 3, 4, 5, 6 members for this one. Okay, so M is equal to 6. And what else do we have here? Let's take a look at joints. So joints are also considered at the supports here. So we have 1, 2, okay, free ends are also joints, 3, 4, hinges are joints, 5, 6, 7, okay? So that's really all you need to take away from this is what is a joint and what is a member. Okay, equations of a condition, EC, those we're going to consider to be hinges. We only have 1. And reactions, we have a pin and a roller, so that's going to be 3. Now, let's just fill out the equation. We'll fill out both sides. So we have M is 6, okay, plus R is 3. Let's do the right side of the equation. We have 3J, J is 7, okay, and EC is 1. So what do we have here? 18, 19, 20, 21 on the left, and we have 22 on the right. Okay, so what does this mean for our solution? So since we have 21 on the left and 22 on the right, that means the left is less than the right. And if we check our equations here, we'll find that we have a statically unstable frame. Okay, so there you go. That's the first one done. Let's take a look at the second one now. So we have another frame here. Okay, let's count the members. We have 1, 2, 3, 4, 5, 6, 7. How many joints do we have? 1, 2, 3, 4, 5, 6, 7. So we have one equation of condition here, okay, because that's one hinge. And we have 6 reactions. Okay, 1, 2, 3, 4, 5, 6. So let's fill out the formula again. Let's do the left side. So we have 3M, okay, plus R, R is 6. And on the right side, we have 3J plus EC. So we have 21 plus 6. That's going to be 27. We have 21 plus 1. That's going to be 22. And if we go ahead and we take a look at the indeterminacy here, we're going to have that 27 is greater than 22, which makes this a statically indeterminate frame. Left is greater than right. Just to find the degree of the indeterminacy, simply go ahead and subtract the left side from the right. That's all. So we're going to say I is the degree of indeterminacy. Okay, and I is equal to 5 here, okay? So this is indeterminate. And this one's unstable. Perfect. Let's go into the third one now. So let's go quickly through these last 2. So we have 1, 2, 3, 4, 5 members. Okay. We have 4 reactions, right? How many joints? 1, 2, 3, 4, 5, 6. And we have 2 equations of condition. Fill out the right side. 3M 3m plus r, okay? And then we have 3j plus EC. So that's going to be 19. Okay, this is going to be 20. So once again, we have an unstable frame, okay? Because left side is greater than the right, this is unstable as well. Okay, now let's take a look at this one. Now, here's a little trick. And okay, if you have a frame structure here and there's no joints and it's completely rigid, so we have rigid connections all the way through, and we have these loops here, okay? So we have girders and we have columns, and it forms little loops like this. If all of these supports are fixed, there's a little trick. And what you can do is you can simply multiply the number of girders in the structure by 3. And what that's going to do is that's going to give you its degree of indeterminacy, because we know that this is indeterminate right away. So let's go ahead and let's take a look at that. That's a little trick that we can use. So we have 1, 2, 3, 4, 5, 6, 7, 8. So I is equal to 3 times 8. So it's indeterminate to the 24th degree. There you go. That's a little trick for you there, okay? So if you ever see a frame structure like this that's completely rigid with fixed supports and there's no hinges, you can just simply multiply 3 times the number of girders here. So that's a girder there. Okay, guys, thanks for watching. Much appreciated. And like and subscribe if you enjoyed the video.